Welcome back to some more geometry. So we are talking about dilations. Now, if you don't know what dilations mean, take a wild guess what you think dilations means. Now, I think the very popular way where we see dilations is like our eyes. Sometimes they get bigger, sometimes they get smaller. Well, that's what dilation is, to making things bigger or making things smaller. So let's kind of look at that. So dilation is or also called scaling, is a similarity transformation where you're able to kind of enlarge things or shrink things proportionally with respect to the center and a scale factor. So we still dealing with scale factor. Scale factor will always be our best friend forever and ever and ever. We're scaling up or scaling down. Now, for example, sometimes the center is outside, meaning like they're reflecting from one side, or sometimes the center is in the middle. It's shrinking down. So it's very similar to rotations that you can rotate within the shape itself, or you can rotate around a circle. You can scale towards or away a point, or you can shrink or enlarge things within itself. So, for example, here, the center for this is somewhere way down here. And the way you kind of figure that out is you kind of connect the points of this. So for example, from here, goes through that point. That means and it hits the exact same spot. It's scaling that way. And then from here, goes, copies that. I mean, somewhere way down here is the center. Ooh, that's weird. Somewhere way down here is the center of the scale. It's scale from here to here. So let's say you scale down. So if you're scaling down, you take the sides, you compare similarity. What my new one is over what my original one is. 4 to 8 reduces to 1 to 2. That means this is half the size of that. We half the size of everything. But let's say we scaled up. We took the big one, the small one, and we enlarge it. So the center is right here and enlarge within itself. So we take our new one over our old one, comparing sides, and that reduces 3 over 2. That means we enlarge this new one is 3 halves times bigger, or 1.5 times bigger than the original one. So that's the scale factor, 3 over 2 or 1 half. So let's look at it in a non-mathematical thing, sort of, because this kind of is but this is our center way out here. These are our original coordinates. Our new one will be the dilation of this with the same center x has a scale factor of 0.5. That means we're going to take these coordinates and reduce them by half. So for example, D right here is 1, 2, 3, 4, 5, 6 units out. So the value is 6 units out, so it'll be now half that. It'll be 3 units out. 1, 2, 3. That's the new D, so we'll call that D prime. Okay, B is 6, so it's 8 units out. So the new B will be half of 8, be 4. 1, 2, 3, 4 units out. This is our new B. We'll call it B prime. A is 7 units out and then up 2 units. So this will now be half of that. So if it was 7 and 2, it would be half of 7. So 1, 2, 3 and a half. And instead of up 2, we go up 1. This is our A prime. And then C, same thing. It's 7 units out and then 2 units down. So it'd be 3.5 units out and then 1 unit down. This is our C prime. Now check this out as we connect the dots. Oh, it's a horrible there. There and there. Let's see if I can kind of clean this up a little bit. There we go. Now let's look at this same shape as far as a diamond, a little bit smaller. It's half the size actually. Now look at this, and I kind of did this on purpose. I kind of drew these guidelines so you can see that when you enlarge it or reduce it, that shape will stay bound between these guidelines. So we were going to increase this to a bigger thing, something much bigger. Whatever it is, it'll stay within these guidelines right here. If it's something bigger, still be proportional in size, but it'll be bound within these guidelines. These guidelines kind of help you see how the transformation is as far as enlarging or reducing. And as long as it's within those guidelines, that means it's still proportional and it's still similar. So let's take that same mentality here. So here we have the point. These are our points. So J, -2, 4. okay, which is at -2, -2, okay, KL, which is -4, -2, and M, which is at -4, 2, okay? These are points. We're doing a scale factor. We're doing a dilation about the origin. So the origin going about the middle with a scale factor of 2.5. That means we're making it bigger. So let's kind of graph these points. -2, 4, 1, 2, 3, 4. -2, -2. Okay. -4, 2, 3, 4, -2, 1, 2. And then -4, 2, -4, 2, 1, 2. All right. Now to get a proper kind of like guidelines, you guide it to the furthest highest point. So this one. So we guide it from here, the center to that, through that, and then just make it longer. Move that a little bit over. There you go. Move that down a little bit. There you go. And then also downwards. So from here, same point, to the lowest point. This is the lowest point, not this one right there. Right there. So this is the current point that we have, the current shape that we have. Draw it out on here. There. There. And so we have this, what we call this, guys? A trapezoid. Yeah, we have this trapezoid that we're going to get bigger. So it should be somewhere. And when it gets bigger, it goes away from the center because it has to be bigger. That's where the bigger side is. When it's going towards the center, it's getting smaller. All right. We're doing blue. We're doing 2.5 times bigger. So that means we're going to take each coordinate value and multiply times 2.5. So get my fancy dancy calculator and take -2 times 2.5. I get -5. So I get -5. And then 4 times 2.5. And I get 10. So -5, 10. So since -2 is -5, so -2 becomes -5, -5. 4 becomes 10, so -4 becomes -10, and then -2 becomes -5, and then -4, 2 becomes -10, 5. So these are the coordinates for our new, bigger trapezoid here. So let's see. So -5, so 1, 2, 3, 4, 5, -5, +10, 1, 2, 3, 5, 6, 7, 9, 10. Ooh, right on there. Look at that. -5, 5. So -1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Look at that. Right on the line. And then -10, -5, -10, -5. 1, 2, 3, 4, 5. And -10, +5. 1, 2, 3, 4, 5. Right there. Now let's draw the guideline. Let's draw the shape. Write it in, and we're doing that in blue. So from here to here, here to here. Ooh, that one's a little bit higher. I should probably put that down. There we go. Here down to here, and then here to there. Look at that. This new one is now 2.5 times bigger than that, bound within the guidelines, and it's proportional. Look at that. Let's do another one now. One more. So we got triangle WXY with vertices at those points, and we're going to graph an image and its dilation with the center. So it's the center's at the origin, so it's going towards or away from the center. We're doing a scale factor of 0.5. That means we're shrinking it. That means it's going to go towards the center. So let's kind of look at that right there. Let's graph our points. So 2, 1, 2, -2, 1, 2. Right there. There we go. 6, 1, 2, 3, 4, 5, 6, -2, 1, 2. And then 4, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5, 6, right there. So this is our line. We're in red. So from here to here, here to here, and there to there. So this is our original triangle, WXY. We are doing a dilation of 0.5, so it's shrinking it. Let's kind of do our guidelines here so we can kind of see. It should be bound within those. It goes from the center. Went too far. From the center right there through that point up there. And from the center right here for that. So it should be, even though it's getting smaller, it's still going to be in here. So let's see how that's going to work. So let's take our pin. All right, so W is at 2, -2. X is at 6, -2. And Y is at 4, 6. Now we're doing a dilation of 0.5. That means we're taking half of everything, 0.5. So times 0.5. So half of 2 is 1. So we have 1, -1. Half of 6 is 3. So that'd be 3, -1. Half of 4 is 2. So it'd be 2, 3. And this is W prime, X prime, Y prime. These are the new coordinates. So let's graph that. So 1, -1. Okay, whew, that falls in there. 3, 1, 2, 3, -1. Okay. And then 2, 1, 2, 3, 1, 2, 3. Look at that right in there. And now let's connect those together. Right there, we're in blue. All right. There, there, and there. Oh, let me drop that one down a bit. There we go. Drop this one down a bit. There we go. Look at that. Now it overlapped, but that's okay. That's okay because it's still, what really matters is as long as it's bound within these two, the overlap doesn't mean anything to us. It just shows that they're still proportional and they're still within each other. That's it, y'all. So pretty simple in this one. You just take your scale factor and you multiply to both the X and Y term to get your new one. Whether you're scaling up or scaling down, do both. Now, when you draw it out, definitely give yourself some guidelines, so some guide markers, so you know that it should stay bound within the. If it falls outside of that, that means we did some math somewhere wrong. And that's it, man. It's the end of chapter 6 or chapter 9. My bad. Y'all have a wonderful, wonderful day. Bye.